Okay, today we are wrapping up our unit on probability and we are looking at Venn diagrams. What these Venn diagrams do is they represent a set of data. So for example, here, this rectangle could represent our entire class. And now let's say A is people who wear glasses and B is people who wear contacts. And then we would obviously have some people who don't wear either, so they would be outside of these circles. So that's just one way you can use Venn diagrams to represent data, but they do have meaning. And first we're going to talk about how to find what part of the Venn diagram we're looking at. So quick review on some symbols and notation. Remember that capital U from way back in chapter 1, this means union. So that means if I take these two things, what do I have together? The upside down U, that kind of looks like an N, is called an intersection. And that would be, where do these two pieces overlap? Now, something that's going to be new is this apostrophe. This means not or the opposite of. So whatever you're looking at, we're going to take the opposite of that. So the first thing we need to practice with these is shading. What part of my diagram am I focusing on? So on number 1, this is my scenario with these boxes, and the first part is just asking me for A. So I am going to shade everything inside of circle A. And that's it. The next one is, where does A intersect B? Well, these circles don't overlap at all, so that is nothing. I'm not going to shade anything. This one is, where do A and not B intersect? Well, we know A is circle A, but let's talk about what not B is. Not B would be everything else but B, so my outside rectangle and A. So what do those have in common? Well, circle A. The next row, A union B. Again, union means what do they make together? Well, that's going to be circle A and circle B. On the next one, not A union B. Well, not A is going to be everything except A. So my outside rectangle and circle B. And then B is just B. So I am going to be shading in everything except circle A. And then lastly, on F, we need to look at what's inside of our parentheses here first. A intersect B. Well, we already know that that's nothing. They don't overlap anywhere. But this not on the outside means everything else. Well, if this is nothing, everything else would be my entire picture. So I'm going to shade in everything. Okay. On the next set, similar but a little bit different, I still have my two circles A and B in my rectangle, but now A and B are overlapping a little bit. So let's see what this changes. This first part is just wanting me to shade in circle B. So there we have it. The next one is not B. So everything I shaded in here or didn't shade in here, I'm going to shade in now. So I'm going to go around circle B and shade in everything else in this diagram. And there we go. On the next one, A intersect B. This time we do have a part where that is taking place. It's this little piece on the inside where they are overlapping. Make sure that's nice and shaded. On D, not A union B. So not A is going to be everything outside of A. So everything around it and the outside rectangle. Now the next part says union B. So that means I need to come in here and make sure all of B is also shaded. So I'm going to be adding in that piece in the middle there. Okay, on E, inside my parentheses, I've got A union B. That would be my two circles together. And then because their apostrophe is there on the outside, I'm going to end up shading in everything around it instead. So not the intersection, or excuse me, the union. of A and B. Okay, and then lastly, not the intersection of A and B. So the intersection is there in that middle, so I'm going to be shading in everything else. All right, there we have it. So, as much fun as this is not art class. These actually do have meaning, and we need to do some math with it. So let's look at a scenario. I've got a class that contains 100 students. 70 of them like math, 60 of them like physics, 40 of them like both. Suppose we were to select a student at random. So in order to calculate each of these probabilities, I first need to fill in this Venn diagram. So M is obviously going to represent mathematics, P is going to represent physics, and then C is going to be my class. So first let's fill this in with our data above. I need to start from the innermost area where these two overlap, so math and physics. Well, I was told that that is 40. I've got 40 people that like both. Now, to fill in this math, I know I have 70 people that like math, but 40 of those 70 like both. So these two numbers together need to give me 70. Well, 70 minus 40 leaves me with 30 people who only like math. Similarly, for physics, I've got 60, 40 of those like both. 60 minus 40 leaves me with 20 who just like physics. And now remember, I had 100 students, and the people represented here so far are 30 plus 40 plus 20. That's only 90. So that means I have 10 people out here who are not part of those inner circles. Okay? Now that I've got all that data in my diagram, let's start answering some questions. So on number 1, first I'm going to shade so I know what numbers I'm looking at. M intersect P, again, that's that inner portion. And then not that. So that means I'm going to shade in everything else. So what I'm going to be looking at is everything except where my two circles overlap. And now why do I do that? Because now visually I know what numbers I'm going to use when I calculate my probability. So again, this is 10, 30, and 20. So my probability is going to be 10 plus 30 plus 20 is 60 over 100. That fraction does reduce to 3 over 5. So there's my probability, my numeric answer. Now what does that mean in the context of this problem? Well, the 3/5 means that 3 out of every 5 students is represented in this green shading. But what does that green shading mean? Well, this is everything except the students who don't like both physics and math. So 3 out of every 5 students don't like both physics and math. I've got some that like one or the other and some that like neither. Okay, let's look at the next one, number 2. I've got not M intersect not P. So let's think about that. What is not M going to be? That's going to be everything around M, and not P is going to be everything around P. So what would those two have in common? That would be the outer rectangle. So that is what I'm going to shade in. And now numerically, I had 10 out there. So this probability is going to be 10 out of 100, which reduces to 1/10. So 1 out of every 10 students is represented. And what does that mean? That means that those are the students that don't like physics or math. And that should say out of every 10 students don't like physics or math. Or maybe they were absent the day this poll was taken. Okay, last one. I've got M union, not P. So this is going to be union, so I'm going to start one at a time, just first by shading in M. And then not P is going to be everything around P. So I need to add in that outer rectangle. And then going back to my numbers, this one's 10, this one's 30, this one's 40. That is going to give me a total of 80 over 100. This reduces to 4/5. So that means 4 out of every 5 students is represented here. And what do those students mean in the context of this problem? Well, this is everyone except the students who only like physics. So that means I've got people that don't like physics, or they like physics and math. So one way you could say that would be that 4 out of every 5 students do not like physics at all, or like both physics and math together. All right, and the video is going to cut me off for time, so I will continue with our 3 circle diagrams in part 2.